Good afternoon. Can you all see the screen?
Yes, sir.
Okay. So last class we have discussed what do you mean by ensemble learning? What is an ensemble? What are the different types of ensemble learning, right? Techniques, and what are the advanced techniques like your stacking, boosting, bagging, right? So bootstrapping, etc. So then the today's class we'll see a little further how does this ensemble learning work? How do you combine? What do you mean by that ensemble, right? So just we will take in a simple scenario. For example, you want to develop a machine learning model. Okay, so you need to create your customized machine learning model that predicts inventory stock, meaning you need to create your own model for your company in order to predict the inventory stock. So what is the monthly inventory, daily inventory, everything. So that is your agenda. So for that you need to develop your own machine learning model, right? So now, so here the data is gathered from the previous year, historical data have gathered from the previous years. Now the agenda is you use train your 4 machine learning models. Here we have 4 machine learning models. We will try with the 4 machine learning models individually, right? One is the linear regression. The second one is your SVM, support vector machine. Third one is the decision tree. The fourth one is your ANN, artificial neural network. So we will use these 4 algorithms and we will feed our input data. If we will feed our historical data as an input and we'll train our model and we'll see what is the prediction, what is a percentage of the prediction, right? So this is in a scenario. So what is the purpose of this ensemble? So what is the outcome of this ensemble? Ensemble meaning diverse group of people are likely to make better decisions. So instead of asking a single fellow, instead of using a single training data set, we will take we will take the different training sets or same training set and we will feed it into different models. Finally, you can apply any one of the ensemble technique like your averaging, weighted averaging or voting. Then we will go for the prediction. So such results always it gives you the better decisions, better predictions. That is what this ensemble learning tells, right? So now the scenario is, now if you feed your historical data individually to these algorithms, this will give you a lesser predictions. So so here when you train your model, when you train your data, when you train your model to individual algorithms, this algorithms gives only 95% of prediction accuracy. So it is not giving more than that, this 95. So what we used to call these machine learning models are weak learners. So we used to call weak learners. It is not giving better accuracy. So such models are we called weak learners. So what learner? Weak learners. So does it mean like it is not the prediction algorithm or it is not, it is a useless? No, the weak learners are not useless, right? But it gives only very less accuracy because they fails to converge at one level, desired level. That is the reason. Here you can see single machine learning model do not provide the desired accuracy. So even you work on various research papers and so on, you might have used an ANN or any other deep neural networks for image classification or something like that. But you might use ANN, GNN, GAN or WAN or whatever it may be, but you may not achieve the accuracy on 92 or 96 or 97, 98. So there are some students that did the capstone project, your seniors, they are unable to predict up to more than 40 or 45. We did snake prediction system. We did those who are my project team, they are doing like those who are wearing a mask prediction system using CNN and ANN, but they are unable to predict, unable to reach more than 91, 92 because of these reasons. So because when you train individual models, individual training models, you may not, but when always the hybrid model, always the ensemble models gives you better accuracy. So meaning you need to take a data and you need to feed it to all the training models and get the results and predict it. Finally, you do for voting, then the better the average of all such results will be you will get. But here you see 80 plus 90 plus 87 plus 92 divided by 4. What is the race? What is the range? So always that either averaging or weighted averaging or the voting, it will give you better accuracy. So such a way we need to train our model. So this is what this objective of this ensemble algorithm. So this weak learner does not mean useless. You can combine them into an ensemble. That is the objective of this. Why there are so many algorithm and programming languages started kicked in? Why can't we stop with C programming? Why can't we stop with Java? Why there are so many programming languages, 1000 plus programming languages? Why should we need? Because of the necessity, because of the in order to solve, in order to rectify the previous versions bugs, we are introducing the new version. So necessity, because of necessity. Same here, if you combine with all other algorithm, you will get more, so you will get better accuracy, right? For each prediction, so for each prediction you run your input data through all your 4 models, right? Then compute the average of the results. So that is what we used to call this ensemble is all about. Take for each new prediction, you run your input data through all 4 models, then compute the average of the results. That is what this ensemble says. When examining the new result, you see that the aggregate results provides 96%, whereas the previous one provides your 95, right? So but here it provides 96% accuracy. Even you may see only just 1%, but the 1% is gives a big difference. So 94.9 is always not equal to 95. That 0.001 or zero point 0.1 is also matters, right? So that is where research stands. So accuracy which are more than acceptable. So the reason ensemble learning is efficient is that your machine learning model works differently. Each model might perform well on some data and less accurately on others. When you combine all of them, they cancel out each other's weaknesses. So this is the best example of your ensemble learning algorithms. I think you might have known, I think you might have understand, right? So this is a very simple way to explain how the ensemble is used. You can see here you can apply ensemble method to both prediction of problems like inventory prediction example. We just saw classification problem such as determining whether the picture contains certain object or not. For example, you might have seen this scenario when you do when you go for various website and Google. So Google's ask you to select the fire hydrants. Then Google asks you to select the buses, right? So similarly, uh, it is a kind of prediction, right? So here the linear regression, support vector machine, decision tree, neural networks. So when you combine all these 4 algorithms, we can make our new ensemble model. So here which gives you the 96% of accuracy, right? So for each machine learning ensemble, you must make sure models are independent of each other. So there should not be any dependency factor between these each model. Now you take your training samples, which is called we used to call a bootstrap, right? You take some training sample from your data set and try to feed it to each algorithm and try to train your model. Finally integrate it. So we have anyway 3 techniques of ensemble. One is a voting, another max voting, another one is your average and weighted average. You can apply any one of these ensemble method, then you can apply that, then you can get the result. So this result will give you a better prediction rather than your normal algorithms directly applying to linear regression or neural networks or any other algorithms, right? So this is the simple way of understanding your ensemble methods, right? I hope you got it. So next is there are two key methods for sampling of data from your training set. There are two key methods for sampling your data from your training set. One is your bagging, another one is your boosting. So these two are the two different techniques generally. Bootstrap aggregation, aka is also known as bagging, takes random samples from the training set with the replacement. That is what we used to call. We will take few random samples and we will train our data set, train the set. So with the replacement. So that is what we used to call bootstrap aggregation. The other method is pasting. We used to draw the samples without replacement. We never do any without replacement. We meaning we will eliminate the samples. There we will never eliminate the samples. So we will see in detail. To understand the difference between sample methods, here are an example. Say you have a training set with 1,000 samples. Understand? You have a training set of 1,000 samples. You want to train each machine learning model in your ensemble with 9,000 samples. You have total of 10,000 samples, but you need to train your model at least with 9,000 samples. I hope you got it. Because you cannot train your model with 55,000 samples. That is 50-50 is not gives you better accuracy. Whenever you use more, whenever you train your model with more samples, you will get more better accuracy. Or else it may not, then you will get some false negative statements. You may not satisfy few test cases. In case you are using a bagging technique, for each of your machine learning models, you take the following step. So first step is, we will see what is a bagging. I'll tell you I think we have seen bagging and all other techniques. So draw the samples from the training set. That is the first one. Meaning we are collecting the random samples from the training set one. Second one, add a copy of the sample to the models training set. We are adding into the models training set. Return the sample to the original set after training. Then repeat the process 899 times, 8,999 times. Because first sample over, remaining 9,000 samples. So we need to do the same sample with 9,000 times, right? So this is what your bagging technique says. You can see this. We'll take some few samples from here, right? Where is my pen? Yeah. So few samples from here. So what we will do, we'll take some samples from this training set and we'll replace them. So when using a pasting technique, you go through the same process with the difference that samples are not returned to the training set after being. But in this, that is what here we are not returning the samples, whereas in case of pasting. But whereas in case of this one bagging, we will return the samples. Same samples will be returned back to the training set. So consequently, the same sample might appear in the model several times when using a bagging technique, but only once when using pasting technique. That is what here. Whereas in case of your whereas in case of your bagging technique, you are returning the samples. But when you take the second sample, maybe the same sample might be appear. So that is what that bagging is all about. But whereas in case of boosting or pasting, here we are not returning. So for example, if here there is a 9,000 samples, you have taken 50 samples out for training, then remaining 8,950 samples only will be there. But whereas in case of your bagging, if you return back, then again 9,000 samples will be there. For every collection, there will be 9,000 samples will be there. The same sample might have reappeared. So that will spoil your prediction also, same results, right? So that is what you are collecting the same assignments from the same n number of students, similar to that. So that is how it will vary, right? Pasting draws so the samples from the training set and replaces them. So we are not doing such things here. So in regression problem, ensembles usually use the average of the predictions made by the models. That is always gives you the better predictions. So now you can watch, so now not now, you can later you can watch this video, so in order to understand the boost classifier. So now next we'll move on to the random forest algorithm. As I told you, there are certain disadvantages in your ensemble technique. We are moving on to the random forest technique. I told you, right? So what are the different disadvantages here? Not in the upcoming slide. Okay. So there are two techniques of the ensemble models. One is your bagging or boosting. Another one is your random forest. Okay. So we'll see here the one area where ensemble learning is very popular is a decision tree. Okay. So the main purpose of the decision tree is to break them into many branches. So the main disadvantages of decision tree is there is a overfitting, high bias and low variance, right? So wherever there is a overfitting is happening, so it is unable to train the model with the trained data set, but it will gives you poor response. So it will give you poor predictions. So that is the main disadvantages in decision trees. That is why we move on to the random forest. Okay. Random forest is nothing but it is a kind of decision tree, but there will be a more decision tree will be there, not much decision tree. Okay. So that is a kind of random forest, meaning collection of trees, nothing else. Random trees, right? So what do you mean by random forest? Random forest are the ensemble learning method, same for classification and regression. So that random forest is also only for classification and regression, right? So as you know, generally this machine like ML is divided into two. One is your supervised, another one is unsupervised. In supervised, we have seen decision trees. Again, your now this is your regression, like a random forest. So these are all your famous algorithms under classification. This supervision is nothing but classification, right? Classification, regression. Unsupervised nothing but clustering and association. Now decision tree we know, we already seen. Now this is your random forest for regression problems. So ensemble methods are made up of multiple learning algorithm which collectively provides a better prediction as compared to any single one of them. They are made up of multiple decision trees. The output is the mode of the predicted class is nothing but classification. Mean of the predicted value is nothing but regression. So classes are classification, values are nothing but your regression. So this kind of problem can be solved through ensemble learning. So one of the ensemble learning is random forest. Random forest are the machine learning ensembles composed of multiple decision trees. Hence the name is called forest. So there are, it includes multiple decision trees. So we called this as a forest. Okay. So random forests have their own independency implementation in Python machine learning libraries using SCI-kit, scikit-learn. So scikit-learn is one of the famous library in order to implement your random forest. So where this random forest started, when this started, it started in the year of even 28. So then the later upgrade started kicked in. Then finally it reaches 2005. So the professor, emeritus professor of statistics statistics at University of California, he come up with this algorithm, right? So there are two techniques I told you. That is, one is a random forest, another one is a bagging. So bagging is also known as bootstrap aggregation. So what is a bootstrap aggregation? So we will use this bootstrap aggregation in this random forest one. So from your full data set, take samples, generate the tree and obtain the prediction. That is our primary objective or single line objective, right? So we will take the samples from the data set, then we will generate the tree, then obtain the prediction. Repeat the different sample from the same data set, the new tree will be typically formed and make different predictions. Continue sampling, generate the tree in this manner till about n trees are obtained, right? So this process is called bagging, right? So this is your bagging. So generating the sample decision trees, trees from the samples until you reach the entries, right? So this is what your bagging. You can see this algorithm, you can easily understand what is this. I mean, what do you mean by this random forest is all about. Now see here, this is your data set. From this data set, I am taking few samples, I am generating first tree. This is your second tree, then here this is your third tree. So random forests are created. So decision tree 1, decision tree 2, decision tree 3. For each decision tree, we have a decision results, outcomes, right? Decisions. For example, whether the student will pass or not. Suppose if it is 70 above, 80 above, 90 above. Suppose here is this is 40. If below 40 or greater than 40, if greater than 40, this is less than 40. So similarly, then this is pass, fail, pass, pass. So similarly like this. So finally the result is going to be a pass. So this is your fail, this is your pass. So now pass, fail, pass. There are three results. Now I can apply my ensemble technique, either majority voting, averaging. Majority voting, if I take pass, pass, fail. So there are two pass, one fail. So what I will do, so then if I take majority voting, then a pass will be the result. Then final result become pass by applying majority voting. Averaging, if you take, so then obviously that is also it will be assigned with the values, numerical values. Then the averaging also it is more than 2, 1 point, sorry, greater than 1. So obviously this is also will go to pass. So this is how your random forest works. Take few samples from the data set, generate the decision tree, then each decision tree has its own outcomes and the decision. Then for each decision, then what you need to do, you need to apply any one of the ensemble technique, either major voting or averaging or weighted averaging. Finally, you predict the result. So this is another example. So labeled training set is noted. Then from this labeled training set, I am saying taking few samples, sample 1, sample 2, sample 3. From the first sample, I am building the trees on random set of features. Then here also some features. For example, this is a university sample, data sample. From here, I am generating sample from CSE. This is for ECE. This is for MEC. This is for BBA. Then for CSE, I am generating a tree based on only first year's data, on first year features. So this CSE has 4 fields. First year field, second year field, third year field, fourth year field. So I am generating decision tree based on the first year tree. So here ECE, same sample. So based on some condition, this is second year. This is mechanical third year. This is BBA final year. So based on all these things, I am taking some decisions. So decisions are there, class A, class B, class C, class A. So out of which majority voting has been collected, then majority voting final class will be announced. So this is what this stage we used to call bootstrap aggregation. Aggregation is nothing but summation, right? So out of which final class been selected. See here you can see fruit box 1, tree 1, tree 2, tree 3. So all are fruit box examples. Here I am checking decision tree. If the diameter is greater than 2, if the color is red or not, if the diameter is 1 or not. If it is diameter greater than 2, true not, then apple or orange. If it is a false, cherry. So here we are finding the fruits. So now here this says orange. Then if the color is orange, then apple or orange. Then if it is a true, then it will be orange. So again this is cherry. Again here orange. So final outcome is orange. Meaning here this is a bootstrap aggregation. They will apply the max vote concept. So max vote is only 2 orange. Orange is 2. Then your cherry is 1, right? So then your max vote wins. This is what your random forest. In random forest, there is another term called out of bag. So what is the out of bag? Out of bag is nothing but a simple word I will tell you. Out of bag is nothing but when we will use this out of bag, whenever you do bootstrap aggregation, when you combine all the results and you are planning to take decision, no, so there your bootstrap aggregation will work, there your out of bag will work. So when bootstrap aggregating is performed, two independent sets are created. One set is bootstrap sample, is the data chosen to be in the bag. So here, from the samples, this will be in the in bag, out of bag, right? So here few samples are selected samples are in the bag, selected samples. Here not selected samples. So all the not selected samples are we used to call out of the bag. So this is not used for the sampling. So we used to call out of bag data set. I told you that assume there are 10 sample sets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples. For first time I am doing sampling with 1. Second time I am doing 3, then 6, 8, then 10. Second time I am doing with 2, again I am doing with 3, then 4, again 6, again 8, again 10. Then third sampling with 7, then 9, right? So now all these samples were selected for all these data sets are selected for sampling, except this 5 all are selected. So now if 5 will go to out of bag. So the data are not chosen for the sampling process. We used to call out of bag data set. Okay. So here you can see there are original set patient A, B, C, D. So A, B, C, D. Here also A, B, C, D, 4 dead patients, A, B, C, D, 4 patients. So here I have 3 bags, bag 1, bag 2 and bag 3. In bag 1, bootstrap sample meaning the sample which are considered for sampling. So A and C are considered here from this sample. So C and D are, C is considered, A and considered. So B and D are out of bag because not considered for the sampling. Here in bag 2 all are considered for sampling. In bag 3 again B and C are not considered for sampling. So now these are the out of bag sampling. These are the out of bag sample set. Okay. So you can see the types of sampling. One is a random sample. Random sample is nothing but there is an equal probability of selecting any particular item. There is an equal probability. So you can select random sample. Sampling without replacement. Sampling without replacement meaning once an object is selected, it is removed from the population. For example, from this population, you are taking for sampling, then what we will do, that item will be removed from this original data set. So that is what we used to call sampling with replacement. When you remove, then we will say, so without replacement. If it is not removed, then we will say with replacement. The selected object is not removed from the population, then we will say it is with replacement. Okay. Then stratified sampling. Stratified sampling is nothing but partition the data set, draw samples from each partition proportionally, that is approximately same percentage of data. Meaning you should have equal contribution from each clusters. See here, 2 is selected from, 1 from yellow, 1 from green, 1 from blue. So 1 has been selected from the stratified sampling, right? Cluster meaning same samples were selected, same group of yellow lace, everything yellow selected. Random sampling with replacement. Random sampling with replacement is selected object is not removed from the population. See here, the one is selected, the same one is not removed, it is there available, right? But whereas in without replacement, that will be removed from this population. So 9, 3, 4, all are Unix numbers. But here it is that will not be removed from the population. So this is how the types of sampling, because you all come across all these keywords when you work on research papers or works, right? So now sampling with replacement, you can see here example, the training data set has cat, dog, horse, cow and rat. So first one is cat, dog, horse. This is your first decision tree. The second decision tree is cow, dog, dog. Then decision 3 is rat, horse, cat. So bootstrap sample of 3, right? So now here when you say bootstrap sample, the logic is we are taking few sample from the data set. So now assume this is your table, this is your table, main table, 4 rows. Here I am considering only sunny, sunny, sunny. So windy is left over. So this is your actually this is your OOB. Okay. So this one is not selected. So out of bag sample. So we used to call this out of bag sample. We will consider only the first 3. What do you call? Yes, no, and yes. So finally there are 2 yeses. So majority voting. So yes will be the winning. So that is how your random forest works, right? So random forest is generally an ensemble classifier made using many decision tree models. So these ensemble models combines the results from the different models. So that is a main view of your random forest. Right? So all the data, then subdata, subset from the subset you generate the decision tree. Then bottom we will apply ensemble algorithms, right? So the same steps were given, you can go through later. So now here same, the random forest is a versatile algorithm capable of performing both regression as well as classification. So that is why our people will go with the random forest. This is suitable for both regression and classification problems. So it is used to commonly predict predictive modeling and machine learning techniques. So the advantages of random forest are it can be used in classification and regression. At the same time, it is used to solve the problems of overfitting as output based on majority voting. Then performs well even the data contains null values, missing value. Decision tree is created is independent of each other, highly stable, maintain the diversity. The tree does not consider all the attribute when you come for dimensionality reduction. So we don't have to segregate the data into training and testing data here. In previous model, decision model, we need to segregate training data set, testing set, validation set, etc. Here nothing you need to do, right? There are some disadvantages. A random forest is highly complex, right? Pointer, pen, yeah. So this is highly complex when compared to the decision trees, where decision trees can be made by following path of the tree, but here you need to construct the different path of the tree, right? So training time is more complicated to other models due to the complexity. Whenever it has to make predictions, each decision tree has to generate output of the given input. So because you are generating the different decision tree, at the same time you are feeding the training sample to each decision tree and you are training the model for n number of times. So obviously it will take more memory and the more complexity, right? So that is your biggest disadvantage of random trees. Challenges of ensemble algorithm overall. One is it requires it requires more memory because you need to store and train the model. Another one is explainability while adding new models to ensemble can improve its overall accuracy. At the same time it is makes it harder to investigate the decision made by all the AI algorithm. So you need to wait for the all the AI algorithm to be clarified and explained and it to be trained. So that is why it is one is your lot of memory, another one is your explainability. So finally, as with the most everything you will encounter in machine learning, ensemble is the one of the most used, frequently used model for your classification and regression. Also, it is allow you to solve more complicated problems. So there we go with your ensemble techniques. When your problem size is bigger, then we'll go with your ensemble algorithm. Either you'll go with random forest or you'll go with bagging or boosting techniques. Okay. Applications, your online targeted marketing, credit card fraud detection, text analysis, your credit risk and insurance risk, retail sales prediction, biological and medical research, manufacturing and quality control. So these are the reference. So I'll be giving you few problem statements. If you are free and if you want to try something, you can try even in our lab. The problem we'll tackle is predicting the maximum temperature for tomorrow in our city using 1 years of past weather data. Right? So you need to predict the maximum temperature, tomorrow's temperature. What will be the tomorrow's maximum temperature in Vijayawada city by using the past year's data, right? So that is one of the problem statement using random forest. I given a collab link also. You can try this. The second one is predicting the gas consumption. So predicting the gas consumption. So to solve this, you can use your scikit-learn Python library. So third one is predicting the whether the bank currency note is authenticate or not based on the 4 attributes. So that we can say. So these are the steps. Import library first, importing data set, preparing data for training, feature select scaling, training the algorithm, evaluating the algorithm. So this is how your random forest and ensemble learning algorithm works. So in lab part, so we will try all these algorithms one by one, right? So this is how your first unit. So with this, we are winding up with the first module 1, learning problem, perspective issues, concept learning, version space, candidate elimination, inductive bias, decision trees, ensemble learning, and for random forest. Tomorrow I'll start with training models, linear regression. The second unit will go with linear regression, logistic regression, and gradient descendant, and k nearest KNN algorithm. Okay. Okay, so with that we have finished the module 1. So if you have any doubts, you can ask. So when is your cat to 1? So end of February?
Feb 26, sir.
Feb 26. 28th. So okay, we have 2 more. Let me check the calendar. 28th, then that is last month. We have full 2 weeks. So okay, we'll wind up with the second module. No issues. Okay. Okay. If you don't have any questions, you can leave. Thank you.
Sir, for us, when is college going to open, sir?